Somebody logs on, they can follow with us wherever they are. Okay, good. This is still working. All right, so basically all we're doing is taking the stuff that we did over the past 2 days and working backwards, okay? We've already done the whole process of derivative and integration. We're just throwing these in here now, which is going to be completely different next year because they will be included during the regular derivative and integral notes. But anyway, we're kind of playing catch up right now. So, we looked at this yesterday. If we're taking a logarithm or an ln, then the derivative is 1 over x. It's very rare, if ever, that you see like an integral of, you'll see like an integral of 1 over x ln of 4 dx. I don't know personally that I've ever came across that, but this would basically, if you do see it, it would be a log of base 4 of x plus c. Honestly, I don't even know that it's something you need to write down because I don't think I've ever seen it. But one thing we do need to keep in mind is when you are asked to find the integral of something like this, either 1 over x dx or 1 over u du, whatever, your ln has to have the absolute values around it because you can only take ln of a positive number. So the absolute value there is important for almost every problem. If you see something like x squared plus 1, that's never going to be negative, so it's not necessary to have the absolute value bars. So you just kind of have to look at every problem and ask yourself, are the absolute value bars necessary or not? And if they're not, you get rid of them. So anytime you see something to an even power plus another number, that's never going to be 0. If you see x minus 1, that can be 0 or negative depending on the x value, so you need the absolute value bars there. So it's just something to think about. Okay? Good? All right. So we're just going to run through examples now. I don't know how many examples I have, a bunch, like I said. Start out with some simple ones and we'll kind of build up from there. And we'll just see what we can get through. I think I have like 9 or 10 examples, so we'll just see what we can do. All right, so first of all, when we see this, if we have just a number up top, move it out front. So this is the same thing as 2 times the integral of 1 over x dx. It is an indefinite integral because we don't have numbers on our integral symbol. So that means we need a plus c. So we have 2 times ln of absolute value of x plus c. Okay? Now, there is another way to write this. And what is it? What can we do with this? Right, this 2 out front here, because of properties of logarithms, can become an exponent. And then what else do you notice? If I have that as a squared, we don't need the absolute value bars anymore because it will never be negative. So ln, we could just write this as x squared plus c. Okay, either of those would be acceptable. Again, multiple choice test, you're looking for the answer that you have, or how can you change your answer to make it match one of the answers that are available. Okay, now for all of the use substitution ones that we've done, this is no different, okay, because we recognize that if I take the integral of an x, I end up with 1. So if I'm starting with a 4x, I'm going to end up with a 4. Not a problem because I can divide it over, right? So this is a u sub, and I'm going to say u is equal to 4x minus 1. Derivative is just 4 dx, right? And we're going to divide that over. I'm not going to do this every time because that's a waste of time to do that. Typically what I do is I just scribble it out here and write it over here so that I'm not wasting time rewriting this whole thing. So from now on, that's what I'll do, but just wanted to throw that in there for the first one. Okay? So we know now that we have the integral. Let me kind of separate this here. We have the integral of 1 over u times 1/4 du. Yep. Good. Take the 1/4 out front. You can rewrite it in this step like this if you want, but again, in my opinion, I think that's a waste of writing a step, because if you recognize the constant's going to go out front and then the integral of 1/u is ln, you know, no need to really write this step. Definitely want to make my u's look more like u's and not so much like 4's. So anyway, 1/4, the integral of 1/u is ln of u.
Interruption. Would Alex Geyser and Connor Treese please report to the main office? Alex Geyser and Connor Treese to the main office. Thank you.
Ln of absolute value of u plus c. And then we know that u is equal to 4x minus 1. Are the absolute value bars necessary here? Yes, because 4x minus 1 could be negative, right? If x is 0, we have a negative 1, not okay. So if there's a possibility for this to be 0 or negative, the absolute value bars are necessary. Okay? Good with that one? Okay. Next up. I'm just going to scroll that up a little bit here. I'll come back down. Okay, so starting off, let's set it up. So we have the integral. We're going to have limits here, right? Or bounds, lower bound and upper bound of this function x over x squared plus 1 dx. Do you know either one of these? We know, is that top or bottom? The top one. We know that the top one is 3. Now, if we're talking about the x-axis, what do we know about when we're dealing with the x-axis? What do we know? What is 0? Always? In this case, it is. Okay, in this case, it is 0. But being that this is the x-axis, that tells us that y equals 0. So then we need to ask ourselves, what makes this 0? And that's 0, right? So, so you're right, it is 0, but it's, you know, just in general, like that's what makes this whole thing 0. So in this case, it is 0. Okay, and if we plug 0 in there, it's not undefined. We have 0 over 1, which is 0. So we have our setup now, so we're ready to do our integral. Okay? So how do we take the integral of this? What do we do? Yep, because we noticed that the derivative of x squared is 2x, and I have the x in the numerator, so I can do u sub and say u is equal to x squared plus 1. Therefore, du is equal to 2x dx. And then, since I don't have a 2 up here, I need to move it over, so scribble, 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 or erase, whatever. Just don't move it over as a 2. Make sure you're dividing and you got the 1/2, you know that. So for my x dx that's right here, I will substitute in 1/2 du. And then x squared plus 1 is u. Okay, are you ready? Yep, okay. So integral from 0 to 3 of 1 over u times 1/2 du. Okay, so I'm going to do this in one step now. Now, I'm actually going to do this 2 different ways. First of all, let me do this. So we have 1/2. Okay, that just comes out front. 1 over u is ln absolute value of u. And we can evaluate this from 0 to 3. Okay? Now, if we do this, before I do this, before I do that, I don't need a plus c, but before I do that, I need to replace my u with x squared plus 1, evaluated from 0 to 3. Or, if I leave this like this, what are the upper and lower bounds? Do you remember that? I think I only did one problem like this, so do you remember how we change that? If I'm leaving this in terms of u, how do I change my lower and upper bound? Do you remember that? Right, so if we want to change this, then we have to come back up to what u is equal to and plug those values in. So what happens when I plug 0 in? You get 1, and what happens when I plug 3 in? You get 10. Okay, so either one of these, I'll underline them in different colors, either the red one or the green one are acceptable. They are equal to each other. They will give you the same area. But it's just a matter of changing the bounds to leave it in terms of u, or plugging what u is equal to leave the bounds the way they are. But it doesn't matter. It gives you the same thing. Okay? So I'm going to do the first one just because it's more work. The other one's less work. You have 1/2 ln of 10 minus 1/2 ln of u. It's the same thing. We're going to get the same thing here. So plug 3 in, right? So I have 1/2 of ln 3 squared plus 1 minus ln of 0 squared plus 1 with my 1/2 out front. Okay, am I going too fast, or you're with me? Okay. So 1/2 bracket ln of 10. Do I need absolute value bars? No, 10's already positive, so we don't need them. So ln 10 minus ln 1. Again, not necessary to have the absolute value bars there. Now, do you remember from pre-calc, what is ln of 1? What is it? This is saying if you have ln of 1, this is asking you e raised to what power gives me 1? There we go, 0. So this is 0. So I can just get rid of it, right? So I'm left with one of two options. Again, we're going to look at our answers to see which one is, asking, or which one is available. This is one option. What's the other way we can write that? Exactly, square root of 10. Okay? Either way you write that, doesn't matter, same thing. Again, looking at multiple choice and seeing which one is there, okay? Are we good with that one? Yeah? Okay. So this one probably looks a little more intimidating, but it's really not. It's actually a lot easier than that last one, because not only do we notice that the derivative of the denominator is an x squared, but you actually get the exact same thing that you have in the numerator. So when we do our u sub here, it actually is much easier than that last one. It's fewer steps and everything. So du is equal to 3x squared plus 1 dx. So we don't even have to do any manipulating or anything like that. We just leave it right the way it is, because we have that exact same thing up here already. So we got the integral of 1 over u du. So ln of absolute value of u plus c. We need our plus c because we don't have numbers there.
Please excuse the the interruption, would the members of the bocce ball team please report to the main office at this time? All members of the bocce ball team should be dismissed and report to the main office at this time.
So, am I putting absolute value bars around this, or can I get away with just parentheses? Absolute values, exactly, because x cubed plus x could be a negative number. Pick any negative number and plug it in, and you get a negative, okay? So, absolute value bars are necessary there. Okay, any questions on that one? All right. Okay. What do you think? Okay, so that's, if you recognize that the derivative of tangent is secant squared, that's perfect. You say u is equal to tangent. But what I'm going to do here is I'm going to show you what I see happen a lot, because people want to, because of chapter 5 in pre-calc, when you see stuff like this, you're kind of tempted to simplify it, right? So secant squared is 1 over cosine squared, and then that's over, and tangent is sine over cosine. So if we try to simplify this, multiply by cosine x over sine x, same thing up top here, cosine x over sine x, these are gone. This is gone with one of these, so we're left with 1 over cosine x sine x, which is the same thing. 1 over cosine is secant x, 1 over sine is cosecant x. So you might be tempted to like, oh, well, that kind of looks familiar, right? Like it kind of looks like one of our trig integrals, but it's not, because the trig integral is secant x cotangent x. Okay, so doing this actually gets you nowhere. Okay, so what you started off with is perfect. That's exactly how we want to start that. But I just wanted to point that out, because I do see that happen a lot, because it's tempting, right? Like everything that you've been taught about these, you start thinking like, okay, let me try and simplify it first. But this is where knowing your integrals really well pays off, because if you see that and you're like, oh yeah, tangent, integral of tangent, or the derivative of tangent is secant squared, then you automatically know you can use u sub, and when you take the derivative, you're going to end up with secant squared x dx, and that's exactly what you have there. So that's what we're going to do. So integral 1 over u du. And hopefully you do a lot of these to the point where, not a lot, enough of these to the point where you can say, okay, well, this is going to end up with 1 over u du, so I know it's ln of tangent, and you can just kind of jump right to that answer without showing the middle steps. But you know, we're taking baby steps, so I'm just going to do it a little bit at a time. So this is ln. Do I need absolute values? Yes, because tangent can be negative. So there's your final answer. Okay? Maybe we will get through these. We're just trucking along. All right, what do we think about this one? And what do I get? What's my derivative? Right. So we, in one step, factor out a 2 and divide by 2 to leave us with the numerator. Okay? So 1/2, the derivative, I'm sorry, the integral of 1 over u is ln u, absolute value of u, plus c. do I need absolute values? Yes, why? Can you give me an example? -1? Exactly, because that will be 1 minus 2, which is a negative number. So yes, absolute value bars are necessary. We could, again, take that 1/2, make it a square root, and have the square root of all this. You're just looking at your answers and seeing what you got. So that is another way of writing that, if you choose to do it that way. I would think instead of a square root, you'd probably be more likely to see an answer like this. Than you would see it written as a square root. Especially with the absolute value. Now, squares, you might see the square up there because that drops the absolute values. And I mean, even with a square root, just inherently, they have to be positive. So, they kind of, that's how logarithms and square roots are kind of similar in that way as well. So, but, there's just multiple ways of writing the same thing. So it's just good to see them written different ways. Okay? So this is, where I would give you the opportunity to try some problems. So if you want to try this one, I'll put a couple more. This one, I'm actually going to go over that one and that one too. So why don't you just go ahead and try that one, and then. Are you good? All right. So let me finish this real quick, and then I'll put it up there. Did you keep the absolute value bars? Yeah. So we're going to need them. And that's what I got. Good? Awesome. Now, this is something I don't recall if I ever went over these type of problems with you or not. So, first of all, what I'm going to do is take the 2 out front, because it's a constant and I don't have an x squared to give me 2x unless I multiply that out. And if I multiply that out, I end up with something that the derivative doesn't really help. Okay? So if I do this, what do you think? It's right. It's kind of like a chain rule, which chain rule is another. So if you recognize chain rule, the integral version of that is u sub. Okay. So now the question becomes, well, what do I set u equal to? Because regardless if I use x or x plus 1, neither of them has the derivative in there, right? So if that's the case, you choose the more complicated one. So we're going to choose x plus 1. Leave a line there, okay? Leave a space. And then we'll do the derivative. du is equal to just dx, okay? You with me? So far, what I'm left with is a u squared on the denominator and a du. But what do I put up top? Because I kind of have a problem here, and this is something I don't know if we talked about this before or not. So So we want it to be in terms of u, right? We don't want any x's there. So what do we know about x? Exactly. This is just an equation. We can manipulate the equation however we choose. And in this case, we're kind of at a standstill unless I know something about x that's just in terms of u. So if I subtract 1, I'm left with u minus 1. So over here is u minus 1. Now the reason why this helps us out so much is now I can split this up. Because if I have one thing on the denominator, I can do u over u squared, and I can do 1 over u squared. So I'm going to leave my 2 out front, bracket, integral. So what's u over u squared? How can we write that simpler? That's just 1 over u minus the integral 1 over u squared. We can't do anything with that, so 1 over u squared. Oops. du. Try and squeeze that in. Okay? So 2 times the integral. Nope. I didn't want an integral there. I wanted a bracket. Sorry. Bracket. What's the integral of 1 over u? Yep. Do I need a plus c there? Yeah, remember c is just representing the constant, so we don't need a plus c for this one and this one. We're just going to put 1 plus c out there at the end. Minus, what is the integral of 1 over u squared? So remember, same thing as u to the negative. At least you didn't fall for the trap of ln of u squared, because that's what I see a lot. People are like, oh, it's just ln of u squared. That only, ln is only for when the variable in the denominator has a power of 1, okay? If it's squared, we just go back to our power rule, which just says add 1 and then divide by that number, right? So to simplify that, I have plus 1 over u, okay? Yeah. And it's, I mean, it makes sense because that's what we've done the last 6 examples or whatever. That's what it was. So, okay, doesn't really matter where the plus c is. We just need a plus c in there to represent our constant. Some people will put it on the inside and then distribute the 2 through and have plus 2c. But 2 times a constant is still a constant. So, for the sake of this, it doesn't really matter. When we get into some other stuff, like the logistical stuff in future sections here, it will change because we're going to have 2 separate constants and they'll be different constants and they'll have to be represented separately. But we don't need to worry about that yet. That's coming later on. The last thing we need to do here is just plug in what u is equal to, which was x plus 1, right? So, 2 ln x plus 1, still need absolute values, plus 1 over x plus 1, and I would leave it like that. What you don't want to do is make each of these squared, or I'm sorry, you can make this one squared, and you can make this 2 over x plus 1. As far as, our ultimate goal is to simplify it, so if it doesn't help you to simplify, there's no reason to do it. Okay, so this is just the same as whether you distribute the 2 through or not. So I would just leave it like that. Save yourself a step. Okay? I think I got one more left. Yep. What do we think about this one? Do you notice something that its derivative is in there? mean, let's look at the two parts. What's the derivative of x? 1. So we have a 1 there, but that doesn't help us with this. What's the derivative of ln x? 1 over x, and that takes care of this right here, right? So if we say u is ln of x, then du is 1 over x dx. Okay? And we have that right here. We got, if I just kind of do a funny little kidney bean thing looking there. Actually, it looks like Pac-Man eating ln of x or something. But anyway, like that's, we have that there. We can replace it. So all we're left with here is integral of 1 over u du, which we know that's just ln of absolute value of u plus c. And what's u? ln x. Do we need the absolute value bars around ln? So we know we can't plug negatives into ln, but can ln be negative? Yes. So we do need the absolute values. Everywhere between 0 and 1, ln is negative. And then from beyond 1, it's positive. So we do need those in there. So that's your final answer right there. Okay? We made it. I really didn't think we were going to get through all those. I mean, just barely did, but we still did. Look at that. And if I would have been down here at the beginning of class, we would have had an extra minute for you to write down these problems.